Arab Zaman. I serve as the director of Southern Plains Transportation Center. Uh, on behalf of my colleagues at SPTC, I would like to actually welcome you to this uh, wonderful event. Uh, so I'll just give a couple of logistic things that the uh, the presentation will be available on the SPTC website along with the video, a PDF of this. If you're looking for professional development hours, PDH, that would be given based on your login time and log out time. So please, if you want to get PDH, then you need to remain logged in. Otherwise, I think that's what we will do in order to check your attendance. Uh, so today we have a very interesting topic. We are actually an important topic in the bridge area. We are trying to do, some balance between, different types of topics. So today we are going to listen from Ed on bridge concrete repairs and preservation using hydrodemolition. It's a very practical and important and interesting topic. So I'm going to request Walt Peters, Assistant Division Engineer of Bridge Division, to introduce Ed. But I would also like to note that this particular event is co-sponsored by Oklahoma Department of Transportation and also by ABC UTC, Accelerated Bridge Construction UTC at Florida International University. And my special thanks to Walt for recruiting Ed, for this event. So with that, I'm going to turn it over to you, Walt, to introduce our speaker.
Good afternoon, everybody. It's my pleasure to introduce Ed Leperotti. He's done several jobs in Oklahoma. Look forward to this presentation. He gave a similar presentation recently to our Midwest Bridge group and did a marvelous job. Ed Leperotti is a PE, Chief Engineer of Hydro Technologies and Modified Concrete Suppliers. He's company specializes in preservation of bridge decks. They operate robotic hydraulic equipment that is safely used to prepare the surfaces of bridge decks for new latex modified concrete overlays. A new structural bonded concrete overlay placed on hydrodemolition prepared surface can be performed with accelerated construction schedules, cost effectively, and will extend the service life of bridge from 25 years, and I imagine a lot of times we get 30 years even. Hydrodemolition technology has evolved over the last 50 years and is the subject of this presentation. ODOT has been involved with these type of construction in years, and it makes for a good research topic. Ed graduated with a BSCE from Youngstown State University, previously employed by the Ohio Department of Transportation, another ODOT, is a registered professional engineer in Ohio, likes golf, fishing, walking, boating, and great outdoors. You will note there is a chat box, and if you have questions about this presentation, please put them in the chat box and address them to Walt Peters. With that, well, Ed, it's all yours.
Well, thank you, Walt, and thank you for inviting me to present to this group of your colleagues. And with that, I'm going to start the presentation with a short video that's just going to give you an animated idea of what hydrodemolition is. So let me do a share screen here. And after that, I will do a PowerPoint, and then I'll open it up for questions.
Used to prepare bridge decks for new latex. Fast track hydrodemolition is a method used to prepare bridge decks for new latex modified concrete overlays. A bridge deck can be prepared quickly, cost effectively, and the high strength bond achieved between the existing deck and the new LMC overlay will assure a 25-year repair. On a typical bridge deck work site, you'll see a hydrodemolition pump unit where the water is pressurized and flow rates are controlled, and a hydrodemolition robot where a powerful water jet is controlled and safely operated. A potable water source from a water tanker or directly from a hydrant is attached to the pump unit. Inside the pump unit, the water is pressurized between 13,000 psi and 20,000 psi, which is the ideal pressure range for selective removal to occur when deteriorated concrete is selectively removed from the structural deck slab without disturbing the sound concrete remaining. The pressurized water is then delivered through high-pressure hoses to the hydrodemolition robot, where the water jet releases from the nozzle and impacts the bridge deck surface. The lateral movements of the water jet and the forward movements of the robot are computer-controlled. Inside the cutting head, the water jet oscillates back and forth and impacts the concrete deck, causing no impact vibration or micro-cracking. The precise mechanical movements of the hydrodemolition robot ensures that every square foot of the concrete surface receives exactly the same water jet energy exposure time. The water jet is calibrated for lateral movements, forward movements, pressure and flow rate to achieve selective removal of all bad concrete in the deck, while leaving a bondable surface for the new LMC overlay, all during one pass of the robot. The water jet attacks cracks and pores in the deck surface and essentially washes away weakened concrete. With fast-track hydrodemolition, you're not removing concrete for depth, you're using it only to selectively remove deteriorated concrete while leaving a rough and bondable surface. Hydrodemolition replaces the need for jackhammering to remove deteriorated concrete from bridge decks. Jackhammers cause damage to the existing deck slab and to existing rebars in the deck. This will affect the bond interface of a new overlay and will greatly reduce the service life of the overlay. With hydrodemolition, there are no fractures left behind, plus a great bond and selective removal of deteriorated concrete is achieved in 75% less time. Modern hydrodemolition equipment is remote controlled, highly productive, and extremely precise. Safety is our #1 concern. The pumps can be shut down from numerous locations throughout the system. Fast-track hydrodemolition continues to be the preferred choice to prepare a bridge deck for a new LMC concrete overlay. An entire bridge deck can be prepared in just one day. With a new LMC overlay, the bridge deck will last for 25 years of maintenance-free service life. There is no proven method better than the fast-track hydrodemolition, combined with a latex-modified concrete overlay to repair bridge decks long-term. Please contact us for additional information and to discuss your bridge deck repair needs.
Okay, well, that gave you a good animated idea of how our hydrodemolition equipment works and attacks the bridge decks and selectively removes the bad concrete. And now I'm going to go through and kind of explain it through a PowerPoint and through a lot of pictures. I like showing a lot of pictures when I present. And I'm also going to mix in some of the really neat jobs we did over the last 2 years and talk a little bit about the Midwest and the work we've done in Oklahoma. And I'm going to follow it up with maybe a short discussion on the concrete we use. And then I'm going to include some of the research projects we've been involved with in the past or that have involved hydrodemolition or concrete overlays. So with that, I'm going to share my screen again and get started with my PowerPoint presentation. There we go. All right. What do? This is what happens to bridge decks, 10, 20 years after. In the Midwest, we use a lot of salt. We have heavy truck traffic now, freeze thaws. It causes the concrete to crack, and then the water gets in these cracks and it freezes and it contracts and expands and it causes potholes. And then the chlorides from the salt get into the steel. That causes rust to build up around the steel, and it also causes that to expand, and it causes pop outs also. So as you can see, bridge decks, they're built from the bottom up, but from the top down is kind of how they deteriorate. And these are all bridges that, you know, if they went much longer, you might have had to replace the whole bridge. But what we're in the business of is preserving bridge decks. There's one over in South Carolina we fixed. Bridge deck preservation, that's something that Walt said earlier that I presented at and earlier this month. And it's what we all do. It's very cost effective to preserve bridges and fix them and make them last longer than it is to just build a bridge, let it go 25 years, and then have to build another bridge. So our bridge preservation partnership really focuses on preservation of bridges, and that's exactly what we do. And what we do is, as a company, we prepare bridge decks and then we install new concrete overlays on them. And we've been doing this for almost 60 years now. So it's nothing new, but there's a lot more products out there and a lot more approaches to it. But when bridges get into the condition of the slides I just shown, that's when you really need to get the hydrodemolition robots out there and the concrete overlays. A couple of the strategies are that I've been involved with was, you know, when I was born in the 60s, there was a lot of interstate being built. Well, in the 80s, that's when I was a young engineer. First job I was ever on, they were doing a concrete overlay. The bridge was about 20 years old. They put a latex overlay on it. It was the first time I ever seen hydrodemolition. I was 18 years old. And, you know, you're getting old. Well, 25 years later, just a few years ago, or it was actually about 10 years ago, they put a second overlay on that bridge. So as you can see, the bridge was built in the 60s. It was overlaid the first time in the 80s, and now it's been overlaid again in the 2000s. Instead of replacing this whole bridge, we're preserving it. And it's a systematic approach, and it's utilized by bridge inspection reports. You got to get to these bridges at the right time and repair them. Otherwise, they get too far along deterioration. You got to replace them. And you know that takes a lot of time and a lot of money. So now I'm going to be talking all about hydrodemolition for the next half hour. It's a mechanical process, like you saw. It's all equipment that does the work. It replaces jackhammers. And what occurs is with that water jet, rapid erosion occurs with that water jet. And the jet attacks the cement matrix and pores and cracks in the concrete. It doesn't cut the stone. It kind of gets in these areas and blows them out. And that's what how we can selectively remove the concrete. And we get out on every deck and we calibrate these robots, the movements, the pressure, the flow rate through the machine, and then the water jet exposure time. Once it's calibrated properly, we'll run it at those settings over the whole bridge, and what we achieve is selective removal. The equipment, as you saw in the video, consists of the pump unit, the power unit, which is the power unit, a hydrodemolition robot, and you did not see a vac truck, but you'll see how we clean up all this debris that's left on the deck. We easily mobilize it to any project. We worked in 24 states last year, and the setup time's easy. We get on a job in an hour, we can be cutting. The pump unit was the first one. As you could saw, it received water from the water tankers or from a hydrant. It's the big power pack that filters and pressurizes the water, and it'll supply it to the units at 12K to 20,000 PSI. And at a flow rate of about 55 gallons a minute, we'll go up to 80 gallons a minute sometimes. It's called the selective settings so that you get selective removal. On the video, it just showed a box with it. Well, we have to be able to get around, so we have that box up on a semi-truck, and that's how you drive it around. And there's a water tanker supplying it. Inside the box, you can see a Cat diesel engine here. That's a 1,000 horsepower engine. And it connects to the Hammelman pumps on the left. That's a 6-cylinder pump. I'm sorry, a 5-cylinder pump. So there's 5 pistons in there spinning, kind of like a gas engine or a diesel engine, but these are creating pressure and flow rate that gets, so all that horsepower from that engine, all that energy gets transferred into the pumps, which gets transferred into the water, which hits the deck. So that's kind of how the power is generated into the stream. The robot's kind of a neat piece of equipment. It's computerized and it's self-propelled. As you saw, the jet, all that water is coming through a 1/4-inch jet nozzle, and there's controls on it that allow us to adjust how much it steps up each time, how much pressure, how much flow rate. We can control a whole lot of things, and from a safety standpoint, we have switches that can shut everything down just at the press of a button. The robot on the job, we have 2 types. This is one that we've built in-house, and we call it the Triton robot. As you can see it operating there, right next to traffic. It's completely safe from throwing debris. And here we are working with one of our Triton robots on a bridge that had fire damage in Kentucky. If you look up the Brent Spence Bridge, Google it, and say 2021 fire, it's quite amazing. A truck wrecked on this bridge right in the middle, and it did a lot of damage, and they got it all fixed in like a month. It was quite an amazing achievement by the Kentucky DOT, but that was a heck of a fire. We just did that in December of last year. Big double-decker bridge. The fire, you could see the fire damage above. The wreck happened on the bottom of the bridge and torched the top really badly. There's one of our Conjet robots that we run, very high productive. And you can see they're 8-foot wides, and they can do a lot of production, do a lot of bridge deck area in one day. And as it works, you can see it selectively finds the bad concrete, and it leaves all that debris on the deck and water. We use a lot of water. And when you clean it up, you can see this is a deck in New York where we selectively have taken out the bad concrete and at the same time left a very bondable surface for the new overlay. The VACOL unit is how we clean these decks. You can see it drives on the decks. It's got a slide, it's got water jets, and it sucks up all that debris and water into a watertight container. And you can see it gets it very clean, because you got to have it very clean when you're putting a new concrete overlay, because the bond is so important. You have to have a long-term bond. It can't debond before 25 years, or we would feel that we failed, that's for sure. And another way of cleaning, when we're doing deep cut hydrodemolition, you can't drive on it with the vac truck, so you have to use the vacuum tube unit and hose. And it's just a lot slower, but I'll explain deep cut hydrodemolition more in detail. So the applications for hydrodemolition, I'm going to talk about fast track hydrodemolition, is what the video was about, and that's how you prepare for latex overlays. And these are to get the jobs done really fast. But then there's a deep cut hydrodemolition I'm going to discuss, and then there's some other applications I'm going to show you, vertical hydrodemolition and some other ones. But if you just look at the cost range here, and when you see the deep cut, you'll see it's about 3 or 4 times higher on the price. The production, we can get a lot done in a day going fast track. Deep cut, you'll see, is about 1/3 of that. You use mechanical milling first. You're going to get a highly bondable surface. We're going to put a latex modified concrete overlay on this type of surface preparation. And I'm going to use 2 jobs that we just did last year. One of them we're going to continue to finish this year, the Toledo Skyway Bridge in Ohio and the Baltimore Harbor Tunnel in Maryland. This bridge in Ohio, it's a beautiful bridge. It's about 15 years old, and the new surface was starting to get a little bit scaly and get some cracks, and Ohio DOT decided they wanted to put a new latex overlay on it. So there we are on day 1. We ran, they wanted to get this done fast, so they called for 2 hydrodemolition units working at one time, 2 vac trucks behind there working. You can see we start at the middle of the bridge because that's the highest point. That way the water falls away from you, so as you clean, it stays cleaner. You can see we've worked our way down from the middle now. There's one of our robots getting ready to start up. And there's the surface that you got, that rough, bondable surface. This deck wasn't very old, so there wasn't a lot of bad concrete in it, but they wanted that rough surface for the new latex overlay to adhere. You could just see the job was 137,000 square yards. It was the biggest job Ohio ever let. So with all that water, it runs from the top to the bottom. We can't dispose of this in rivers or sewers. You have to contain it, collect it, contain it, categorize it, treat it, and legally dispose of it. So what we do is we install, that's just another picture of us collecting the water. We install tanks underneath. We're able to collect this water in these tanks. From here, we can send it through filters if we want, and we could add acids, or like such as citric acid or muriatic acid we use, or sodium bisulfate, because the pH goes up pretty high. If the pH is around a 7, neutral, when we get the water after we cut, it goes up to about a 10 or an 11. So a lot of the sewer departments don't want that high pH, so you have to add acids to neutralize it. So about with every job now, we have to have a water treatment system on, if it's a real big job. If they're small jobs, we'll collect the water, but there's a water control plan that goes with every job. And there's a top view of you can see we put the dirty water in a weir where we do filtration of the water, get the suspended solids out. Then we ran the water through our filtration and pH adjustment unit. And then the 2 tanks on the top, we put it back in where the clean water was. And on this job, we didn't want to dispose of all this water, so we recycled it. We're able to get it clean enough to reuse it again. The next job I want to show you about for fast track hydrodemolition is the Baltimore Harbor Tunnel. This is a heck of a structure. If you want to get online and Google how this thing was built, it's amazing. They built these big steel units, they dredged, and they submerged them down. I never heard of a tunnel being built like that. I always thought they were bored. This one was floated out into the harbor, filled with water and dropped, and then those guys got in there and dewatered them and welded it together. Quite amazing. But after years, there's 2 tubes, as you can see, a northbound and a southbound. And after years, this is kind of a schematic of the tunnel. This thing is over 8,000 feet long. And on the next slide, you can see it's twin tubes. Those are all steel. Then they completely line with concrete. But you can see at the bottom, that's the roadway surface. And that's what was deteriorating very, very badly. So Maryland Transportation Authority said, we got to fix this. We can't replace all that. So they came up with hydrodemolition and a latex overlay. And you can see this is the approach. We're doing phase 2 of the northbound tunnel. On the left, you can see the latex overlay is already completed. I mean, on the right, I'm sorry. On the left is where we're working now. The hydrodemolition units we made, we actually designed these ones to be 11 foot wide because the cuts were 11 foot. We couldn't back up. Very tight work areas, not from really construction or from vehicular traffic. Construction traffic had to be able to get by us because there was a lot of activities going on. Oh, you can see they painted our unit up. The guys had some fun and put some decals on this one. But you can just see how it was working. And now we're finishing the approach. So we're entering into the tunnel. There's the vac trucks working. And inside the tunnel, I'll tell you what, you want to talk about amplification of sound. When this equipment works inside of a tunnel, it gets so loud. The guys have to you couldn't just put regular earplugs in. We had to buy them these $700 pieces to protect their ears. Very loud, very tight quarters, and lots of water. There's a panoramic view you can see where the pump units on the right, the hydro units in the middle, and the vac trucks on the left. Look at all the debris we have to clean up. It's amazing what we do, but we had to clean up. And then at the very low end of the tunnel, you can see where all this water ended up. Well, we had to get a big pump. This was a 6-inch centrifugal pump and diesel powered, and pump it back out of the tunnel over 3,000 feet. And we pumped it up to our system here that we set up at the top of the tunnel. So you have to get water into the tunnel, you got to pump it all back out, clean it, and then legally dispose of it. So there's a lot of engineering that goes into these jobs. It's really, really amazing. And with the surface, it's a very fast way of doing it. We're going to selectively remove concrete, leaves a very rough and bondable surface. It reduces the chloride concentrations on the deck. It's got a lot of bondable area, and we don't cut the steel. It actually cleans the steel, and it makes it look like the day it was put in. It's really amazing how nicely it cleans it. And there's just kind of a schematic of a fast track surface. And there's a calibration area of a fast track surface. That's when we, before you get started, you do some test areas. And your goal is to have it rough, bondable, but to selectively take the bad out and clean that rebar. Look how clean that rebar is. You go from all this debris, and when it's clean, there's that picture again showing the selective removal. If I don't know if you guys have ever been on like a job, and before hydrodemolition, they would go out with chains and they would drag it on the deck after it was milled, and they would get spray paint and spray out these areas, and then the guys would jackhammer, and you would just continue to do that until you got all the bad out of the deck. Well, with the hydro, you can do this whole deck in one day, where it might take a week or two jackhammering and sounding. Plus, you don't have the micro fractures. You get the bondable surface. It just really makes your new concrete overlay last a lot longer on a hydro surface. In the Midwest, they do a lot of this work. I mean, you could just see in Indiana, the 10th of last month, they let out 11 jobs. The 13th, 166 projects they let out with hydrodemolition and latex, 406,000. Illinois, 108 projects. Ohio, Kentucky, Missouri. There's Oklahoma. I've been working with Walt for 20 years doing this hydrodemolition in his state. And in 2020, they let a really nice job, the Pensacola Dam project, and it was 14,500 square yards of hydro and latex. It's going on right now, I believe. Unfortunately, we weren't the low bidder on that one, or I would have definitely highlighted this job. But is there anything you want to say about that job, Walt, maybe?
No, I just think we're getting a really good overlay, and very pleased with what we got.
Good, good. But like I said, Oklahoma's just been a leader in bridge deck preservation, and they're making what they have last and trying to make their funds go further, just like everybody is. And Michigan and Iowa, there are two more that have done it, and that's all part of the Midwest group that Walt and I are a member of, some of the states there. So now I'm going to talk about a second application, the deep cut hydrodemolition. This is used where states feel they have too much chlorides in their deck. So they want to get below the rebar mat, and they want to ensure that they're getting all of the chlorides out so that it doesn't cause deterioration on your rebar. You can see it costs more per square yard, and the production is a lot less than the fast track hydro. And I'm going to use a job that we just finished last year over in Rhode Island, the Newport Bridge. And this is another beautiful suspension bridge over the ocean there that runs from the mainland to Newport Island. And it's just beautiful up there. And it was really, we only did half of the bridge, and I guess they're going to try to do the other half as soon as they get money again. They charge $5 a car, so there's a lot of cars, so I'm sure we'll be out there sometime in the next few years. And you could just see this deck, how much patching they did it on for the years. And there's so much traffic during tourist season that they were very sensitive to that. Work had to be done at night. You had to move barrier daily. You could see all that barrier on the left. That's movable concrete barrier, so that they had 2 lanes coming into the island during the day and 2 lanes going out. And that's how we had to do the construction. And because of that, it took us 2 years to do this job, where, if we could have had the whole bridge, we could have did it in one construction season. But maintaining traffic, keeping your tourists happy, keeping your politicians happy, that's why we have to spend a lot of extra money to fix bridges in phases. So this was a big, another big suspension bridge, very tight work areas. And like I said, it's the deep cut hydrodemolition, and that's where we have to use the tube, the suck tube there, and hosing to get it clean. You can't run those vac trucks on this kind of steel because it would it would bend them, yield them, and weaken the bar. So you have to do it all by hand. You can see, look at how tight that work area is. We had traffic on our left, traffic on our right, and we were right in the middle of it. But there's the final surface. You slow the machine down, and it cuts deeper, and it doesn't damage the steel. And this is what the owner wanted here. Instead of putting an 1.5 inch concrete latex overlay on, he put a 4-inch structural concrete overlay on, bonded to the top mat of bar, while leaving the existing concrete underneath. You can see it's still a very bondable surface, but he wanted every bit of that rebar exposed. You can see some of the marks. They had to have a little bit of jackhammer work after we were done, but very, very minimal. We had to do all the cleanup, extra cleanup at night. So just beautiful skies there. And on this job, we actually were able to set up our water control system over a pier on the bridge outside of the work area. And we took the water and we recycled it, every bit of it on here. So at the end of each phase, we use millions of gallons of water on this job for cleanup and for hydro, but there was 4 phases. At the end of each phase, I only had 20,000 gallons to dispose of. So that saves a lot of money when it comes to, there's nowhere to put it. We're over the ocean. So it would have all had to be trucked away. So I said, let's recycle this one. Just another picture of the recycle operation. And then here's some of the less common applications, but where we have used hydrodemolition, patching bridge decks. Some of these, New Jersey next week's got like 40,000 square yards of patching, and guys running jackhammers, it's just becoming less and less common because the silica dust standards are hard to adhere to. These guys have to wear masks. You have to use water. It makes a mess. And it's just, hydrodemolition is starting to get used a lot more for patching, only on big jobs. It has to be a good sized job. Full depth removals. Sometimes the owner wants the deck taken out full depth in certain areas and replaced. Well, you try to jackhammer all this, you'd be there for a month. So we're able to, he marked out these areas and we're able to blow all the concrete below, catch the concrete without damaging anything below, catch all the water, legally dispose it, don't get the EPA upset, and we don't damage any of the rebar. And they were able to put that deck back, those really bad areas, bad pores that they had. Like a lot of expansion joints get removed. Well, that's all jackhammer work. This contractor asked us to do it with a hydrodemolition. This is cutting, I call it slotting. We cut over existing beams that have connectors on it. I don't know if you could see my pointer there, but there's some there's connectors you could see. Well, they're replacing this deck. All that concrete above the beams would have had to be jackhammered, and we were able to do it with hydro. And it's the same with steel beams that have steel stud connectors on the tops if you replace the deck. Vertical hydrodemolition, we do that also. You can see we prepared the face of that wall for a new surface instead of taking everything down and replacing it. Lot cheaper. They called for all this patching on these piers. There was 50 of them. We went in and did it all with hydrodemolition instead of jackhammering. Here's a big turn back wing wall that they had a bunch of patching on. We got in there and did it with the hydro. We did the face of the abutments. Tunnel, here's another tunnel job. This is in Pittsburgh, the Liberty Tunnel. It was an arched tunnel, and they wanted the walls done. These things are like 2 miles each, 2 tubes. And we went in there and hydrodemolitioned all of those walls, and they applied new shotcrete to them. So I just wanted to, that's all I had to talk about on the hydrodemolition side right now, other than the research stuff. But I wanted to briefly touch on the latex concrete mix design. This is the topping that we use and that they're using on the Pensacola Dam. It's It's a standard concrete mix. You've got your fine aggregates, sand, your coarse aggregates. We use a smaller size stone. You don't use like the 1-inch stones, more like ½ inch, because you want them to get under the bars if you do have bar exposure. Cement, 7 bags of cement. So it's a very strong mix. It'll achieve 4,500 PSI in 7 days. And this is what makes it the modified concrete. They add latex emulsion to it, 24 gallons per cubic yard. I'll talk a little bit more about that on the next 2 slides. And there's the water. The air you're going to end up with is about 7% and a 4 to 6 inch slump. Again, we sell 3 types of the cement. As you can see at the bottom of the page, if we use the type 1 cement latex mix, that requires a 4-day cure. I believe that's what they're using on the Pensacola Dam. If you use the type 3 cement for the 7 bags, 658 pounds per cubic yard, you can reduce the cure to 2 days. And then we sell a third product, the rapid set mix. And this is when you want your bridge deck overlaid fast. I mean, a lot of these states want us to go out there, do whole bridge decks in a single weekend. Well, you can't wait 2 days or 4 days for the cure. This rapid set mix sets up 3 hours. It's traffic ready. It's really an amazing thing. We use CTS cement. We're not affiliated with them, but we've been using their cement since 1990, and it's just a great product. It's used all over the world, and if you really ever want to look at some good rapid set cements, CTS I would highly recommend. Okay, that latex emulsion I talked about, 24.5 gallons per cubic yard. It's a suspension of very tiny styrene butadiene polymer particles in water, typically about 50% polymer, 50% water. These little polymers are very well known for their hydrophobicity or excellent water resistance. These things, when they're introduced into the concrete mix, this 24.5 gallons, and it's mixed all together in the mobile mixer, I'll talk about those, these particles fuse together. They stick, they're very sticky. If you get this stuff on your pants or boots, you can't get it off. They stick to the stone, the coarse aggregate, the fine aggregate, and then when it hits the deck, it sticks there, and they form this like web throughout the concrete. And what I'm saying at the bottom, it essentially waterproofs the concrete. The concrete, as it goes into from its liquid to its solid state, all the water is escaping. We want to control that because you don't want to end up with shrinkage cracking. You do that by wet curing. But as all that water escapes, all of these poly particles are left in the concrete, and it makes it waterproof too. So that's what makes it really good as an overlay material, because it sticks to the deck real good. It gives you that chemical bond, and then it doesn't let any chlorides through it. It essentially waterproofs the deck. Oh, what happened to the slide? Did I miss one? Oh. I might have stuck something in here out of order, but the equipment it's not made in a ready mix concrete truck. It's made in a volumetric mixer because it's so sticky. If you put it in a roto mixer and at a batch plant, it would be stuck to the drum so bad. And it's placed with a Bidwell type finish machine. You can see here the mobile mixer. It's like a mobile batch plant. You have a bin for your coarse aggregate, a bin for your fine aggregate, a bin for your water, and a bin for your cement, and a bin for your latex concrete, all separate. And here's one of our trucks pulling onto a deck, getting ready to pour. And what's great, these are accurately calibrated. They produce fresh concrete. It's all mixed. It drops into the auger. It works its way upward and is mixed in that auger. And then it's placed onto the deck, directly onto the hydro surface. And you can see here, the finish machine is finishing it to the grade and profile of the deck. And that's going to give you your final riding surface. And this one's being done at night because we want low evaporation when we pour this. We don't want shrinkage cracking. And here's a finished deck over in Ohio, going over the Ohio River. It was in pretty poor shape, but we put a new latex overlay on it about 10 years ago. And I just drove over it probably about a month ago, and it still looks great. Those latex overlays really, really hold up. Okay, my last slides, I'm going to conclude with, I was asked to talk about some of our research. And this 1988 was really an amazing research. It was done in Sweden, but that's kind of who invented hydrodemolition. And they determined what the optimum settings were for pressure, flow rates to achieve the selective removal. And it's a really interesting report. It's translated, so it's not great, but if you're in the business, you would read that. The National Research Council in 1992 did a really interesting report on the techniques for concrete removal and bar cleaning on bridge rehabilitation projects. They go into a lot of hydrodemolition there. I can't see the date there, 2000. Successful, the National Cooperative Highway Research Program. I think Walt might have been a part of this. I'm sure he was. This was done by all the states last year. And they did a really in-depth study, got a bunch of people together, a bunch of states to share. It's kind of funny. Every state's got their own ideas on bridge preservation. I know our bridge preservation partnership really tries to make everybody pick the best things that everyone's doing and try to use those. And this hydrodemolition report is an excellent, this scan report that was done. That was just done last year. And I had to give dibs to Mike Sprinkle with the Virginia Transportation Research Council. He's still a part of our latex modified concrete working group. He's kind of the guru on latex concrete. He's done so many studies. If you Google his name, you'd be amazed by how many studies he's done on latex concrete and hydrodemolition. And then one that was kind of fun, the University of Texas did some studies on hydrodemolition and some different types of concrete, fast setting concrete overlays. And that was in 2010, and we were involved with that. And I had some good pictures from that. So I wanted to end my report showing you some of these cool pictures of students and faculty like yourselves working. So here's their civil engineering building there on the left. And they poured 2 beautiful slabs out in their yard, as you can see, for us to do hydrodemolition on and to test different types of concretes. And so then after we were done, they did stress strain, pull-offs, they did everything. And here's our robot getting off and moving on to the slab. And there we were operating for them. And we gave them 2 really nice prepared slides. We couldn't run our vac truck, so we just cleaned it off the side. And look how nice on the left that picture is. It just gives you that. It was brand new concrete, so you don't get the selective removal. You just get the highly bondable surface. And then they built forms around the hydro thing. And then we brought one of our latex trucks down and we poured one of them with the early strength latex. They really liked that, how fast it did. And I think they tried a calcium luminate type mix. And the students got in there and did the work, which was really fun. And we had a good time that day. They cured it how we told them to with the wet cure and put the plastic over it, which is an evaporation retardant. And then they went and, like I said, they did stress strain. They tested all the concrete, compressive strength. They used every piece of equipment in the lab that they had. So here's my questions and contact information. And it looks like I took about 43 minutes, so I'm ahead of time, ahead of schedule. That's good. And we have a lot of time for questions, if anybody has any.
Well, Ed, see that Uriah Nichols asked, why do we need to mill for depth first? I've had a contractor tell me they can just hydro-demo the depth that we want and save on the cost of mobilizing a milling machine.
Yes, that's a very good question. On a small bridge, I agree. Why bring a milling machine out to do 300 square yards? And when the hydro is just going to be there for a day anyway. But as you get to larger bridges, say you get to a 2,000 square yard bridge, so if you don't mill, that bridge is going to take 4 days to hydro, which is an additional cost a lot, where if we do mill first, it'll only take 2 days for hydro. So you have to compare the cost 2 days of hydro and a day of milling versus 4 days of hydro, and you will see that the 2 days of hydro with the milling is a lot cheaper, plus the work gets done a lot faster. 3 days versus 4. That's just on a 2,000 yard job. And the savings is probably $25,000, maybe more. So if it's a small bridge, I agree with the contractor. Yeah, we'll just hydro it. It will take a day. It's gonna, whether we do it milling, milling plus a day of hydro or just a day of hydro, yes. But as you get to bigger decks, it's very cost effective and time effective to mill first.
Okay, please put your questions in the chat box if you have any. Dr. Zaman asked, how does hydrodemolition compare to other bridge preservation methods, cost versus expected life? I don't know if you compare it to thin bonded overlay or what he had in mind exactly, but can you address that, Ed?
I think so. All of these, like Oklahoma DOT, I'm sure has a list of products that they use. Sealers. Sometimes they just put a sealer on the bridge deck. That's cheap, but it's only going to last, what, 5 years? I'm not sure, Walt. Maybe that's probably about right. Then they may do a thin bonded epoxy overlay, and that is going to involve a surface prep with a shot blaster, some jackhammer work, and that may last 15 years. So I think what Walt's division does is they look at the condition of the bridge. They look at, is it going to need work done down the road? Is it going to be widened? And they put a lot of factors into determining what type of treatment they give to their bridge decks. They know the life expectancy of all the different products. And sure, I'd like to say latex, use it on all of them, but that's just not the case. There's a lot of thoughts and a lot of information available now to make really good decisions about your bridges. I don't know if I answered that completely accurately, but there's a lot of products and there's a lot of different bridge conditions, and there's matrices that they can determine what is the best.
Okay. Jason Langhammer wants to know if the cost per square yard is the same for horizontal and vertical surfaces.
The cost is, no, it's cheaper. Like if you look at the cost, the fast track is definitely the most cost effective on a flat surface. The deep cut is, like I showed you, the costs are about a third or about 3 times higher, 3 times slower. The vertical, it accesses the whole, it controls it. It can be the same, but you can just see how tough the access is, and you just don't get the production. So it would probably, like doing that big pier cap I showed and doing the that wall, very small quantities, the cost would be very high. But versus the Liberty Tunnel, we were able to move pretty fast on that one, and the costs were a lot better because it was, plus there was a lot more quantity too. So it's all dependent on how deep you're going and how much quantity you have and how limited your time you can work is. That's for sure.
Wayne Reesner wants to know about epoxy coated steel. Is the time to recoat prohibitive?
Oh, it can. I have some good pictures of that. I wish I could show you. The stones bouncing around do damage the steel. We just did one in Dublin, Ohio, for the city of Dublin, and it had epoxy steel, and I got a bunch of pictures from it. But how the engineer there, he's like, well, if I'm putting an impermeable concrete overlay on it, and for years we put overlays on black steel, if there is damage to the latex, then it's going to be protected by, or as damage to the steel epoxy, then we're going to cover it up with a new latex overlay that's going to prevent the chlorides from getting to it. So it will damage, it nicks it, and it's the older ones, when they used to paint them in the shops, it rips that completely off. But when there's a new process where they put an electric current on the bar and it causes the paint to adhere to the bar. I'm not sure what that's called, but I've seen videos of it at groups and stuff. It just nicks it. The stones bouncing around put nicks in it.
Okay. Patty said our price history for hydro demolition shows 75 to 235 per square yard. And she's concerned that 235 per square yard hydro demolition is not cost effective.
That must have been a really, really small bridge, because we just bid a job in Mississippi. They had 64 square yards, and we had to go there 2 times to do it. And our price was over $1,000 a square yard, just because there was no quantity, and we had to move in. The bigger the job gets, like I would be interested in what the price was on the Pensacola Dam. That'd probably be some of your best hydro pricing there is. I know we were cheap on it, but somebody got cheaper versus some of the small bridges you do. And if you have a small bridge broken up into 4 phases, it's going to be really expensive. So it's cost effective, but a rule of thumb is, and in Ohio, if a bridge deck is less than 200 square yards, don't use hydro on it. Just use jackhammers. That's small, and limit the size of the jackhammers to 40 pounds, so you don't have big jackhammers or hoe rams causing micro cracks in your concrete that you're going to reuse. So the price, it varies on the size of the bridge and how much you chop up that bridge, how many phases it has.
According to John Grant, the Pensacola Bridge was 110 a square yard, just for your information.
Good.
Okay. We got a question about bridge deck patching, that the patch is a lot stronger cementitious material. Has that been a problem for you?
Yeah. That's another important if you have a job with a lot of patches, it's important to mill down, because the existing deck concrete around the patch will be 4,000 PSI. And then that patch could be 8,000 PSI with some of the concretes they're coming up with for these patches. They are hard. And we always want to calibrate on the existing deck concrete, because if you try to take the patch out, you're going to blow all the good concrete around it out. So milling first really is how we have to do it on patches.
Okay. That's all the questions I've seen.
Okay, well, there's my contact information. Send me an email if anybody has any questions or any projects or any bridges you're looking at. I answer them quickly, I promise you that. And it was a pleasure to present to such a large group, and I hope everybody enjoyed it.
Wonderful. On behalf of my colleagues at SPTC, again, and ODOT and ABCUTC, I would like to actually thank you all for taking your time, to join this very informative presentation. A special thanks to Ed and to Walter for recruiting Ed. There are several people that actually helped us make this event possible. Dr. Michael Molina, he moderated in all of the logistic issues. You have received multiple emails from Michael Belly Hopkins, and also Rose Ladd helped. We are doing this we are trying to regularize this type of event. So if you would like to see someone speak, I'm not going to ask you for money, maybe sometime later on, but not right now. So please let us know what topic you would like to see presented, because the whole idea is that we do not need to reinvent, whatever knowledge, like for example, what Ed talked about today is very, very practical. Bridge preservation is a very important topic, and so is pavement preservation, and so on. So I think, so if you want to see, some topics included, just let us know. We will do our best, to get that speaker for you. This has been a very well attended event. If you want to get your PDH, if you indicated that when you registered, you should receive your PDH automatically. And if you do not, please let us know, and we will, make sure that you receive your PDH. Uh, so uh, again, want to thank you all, for making this a wonderful, very successful event. Ed, as I talked to you earlier, that a PDF of your presentation will be available, and also your video of your lecture would be available on the SPTC website. So again, thank you all, and we appreciate everyone's participation to this event. Thank
Bye,
you.
everyone. Thank you.
Thank you very much.